Hi, Jamie.
Hi, Joel.
How's your week going? Week going?
Fine. I'm distracted by all the new buttons in Zoom now.
Oh yeah, there are a lot, aren't there? Breakout room,
Yeah,
whiteboard.
Summary and AI Companion are the two it was just insisting on telling me about.
Oh man, that's what we all need. AI companions.
Yeah.
Very dystopian. Hi, L.
Hello.
Sounds like Brett might not be able to make it, so let's see if maybe give people one more minute or so, and then we'll get started. Use the agenda in the chat here. Oh, we see the chat from last time, it looks like. That's cool. L, would you consider yourself a fairly proficient Python programmer?
I guess so.
Okay. Well, you're
Yeah.
ahead of me then. I have almost no experience with it, so.
Okay. Yeah. Been programming for about 20 years now.
Okay, that
Yeah.
sounds pretty good.
Yeah. But I haven't kept up with a lot of the recent developments.
Hmm.
So I just use the bread and butter of the language to solve my
Sure.
personal project
Yeah.
problems. So it's yeah.
One of the things on the agenda is I need some advice on typing, static typing, type checking support for the code I'm generating in Componentized Pi for resources.
Mm.
And I don't know. I was hoping we'd have someone on the call who knows something about that. I don't know if that's
I do not.
okay.
It's one of the things I hate about Python is how typing was implemented.
Uh,
I refuse to use it.
okay. Well, that's fair.
Yeah. Um,
I mean, the fallback, of course, here is that, we can have typing for everything else. It's just we might have to use the any type in a few places if I can't figure out how to do a better job of it.
I think that's a good place to start. I
Yeah.
mean, it's always possible to cinch it down later,
Mhm.
but yeah,
Yep.
there's no shame in using it in any type.
Sure.
It's just you know,
I'm just a little scarred from my TypeScript days where coworkers would use any just because they didn't want to think about it, rather than actually, coming up with at least, so, and sometimes it's just the nature of the beast because you're interacting with JavaScript libraries that aren't designed to have types
right.
associated with them, and similar in Python, I'm sure.
Yeah,
It's just,
yeah, and pretty much like in Python, the types are not sound, right? So
right,
yeah, so it's just something to help the type checkers.
right.
Uh, it might help you with things like IDE autocompletion and things like that, which is also very nice. But that's pretty much it, right?
Yeah. Yeah, that's the reason I'm doing it. You know, I just want to, you know, for people who are using IDEs, you know, be able to just have like completion, you know, see, okay, what, you know, I need to call this function. Okay, what does this function need? Oh, it needs a string here and it needs an integer here and that sort of thing. And just having, you know, at least the basics in place so that they don't have to wait till runtime, you know, to find out whether it works.
Mm-hmm.
I've done a little bit with MyPy and type checking.
Mhm.
I would hardly say I'm an expert, but be curious to dig into more what specific questions.
Sure. Yeah, I mean, I guess we can go ahead and start here. We've given people plenty of time here. Let me go ahead and share my screen real quick, and we will take a look at it. Share. Okay. Let me go over here. The font's really small here. I'm gonna make that better. All right, I should have set this up earlier. It was so in particular, the particular case I'm looking at here is this line right here. It's line 18. I'm just using Emacs here. It's not actually labeling the lines, but so we can see we have a little interface, and all it does is define a single resource called thing, and it's got a constructor that takes a U32, and it's got a couple of functions, and then it's got a static function. So resources can have static functions. Which don't, you know, the idea is that the code generator for whatever language is not supposed to provide a self parameter. It's just something that you can call essentially as a freestanding function, and you're just using the resource as a namespace. But you can also refer to that same resource with, you know, within the parameters and the return type of the static function. So here we have just, you know, trivial example, static function. It takes two things and it returns a thing. Who knows what the semantics are? It doesn't matter. And so the question comes up: how do we generate well-typed, you know, statically typable code for this? And the issue that you run into is that apparently the way we're doing this here is for each of these. Actually, let me back up here. For the Rust code generator for resources, what we do is we generate a trait for each resource, and then it's the responsibility of the application developer, if they are exporting that resource, to implement that trait with their own implementation. And then so these things would be in Rust parlance, these would be capital S self parameters, and then it would return self. And the self would be in Rust, it would be very unambiguous. It's not necessarily, it's whatever concrete implementation of that trait, it's that type. So if the trait's called thing and the concrete type is called my thing, that impulse thing, then it'll just, you know, then self returns to my thing in that case. It's tricky in Python typing because here, let me go over here. Let me see if I can generate the bindings real quick, and we can take a look at what I'm currently doing. Oops, just a sec. Ignore the man behind the curtain. Sorry, I was in the middle of doing something else. Hopefully this code actually builds. But what I was going to say is with Python, the closest equivalent, in my understanding, of course, I'm a Python newbie, to a trait is an abstract base class. There's this ABC package in Python, part of the typing kind of, maybe it's not part of the typing, but it's an ABC package, abstract base class. And so you create this abstract base class with a bunch of functions, a bunch of methods on it, all of which just return raise not implemented error. So we can kind of see that here. This isn't the example we were looking at before, but we'll scroll down to it. They has a bunch of abstract methods, and they all have, if they're just methods, they take self and so on. And so you just label them abstract method. And if you have a tool like MyPy, and even actually there's some, it's not even just MyPy, but the Python interpreter itself will see, oh, it's abstract method. You can't create a subclass of this thing unless you actually, you can't create an instance of a subclass of this thing unless that subclass overrides all these abstract methods with concrete implementations, right? So kind of what you'd expect from a trait, or like from a C++ abstract, pure virtual base class or whatever. Okay, so we're good there. Let's see, going back down to, oh yeah, so this thing. So actually, wait, sorry, where's the, keep saying, I've got like 40 resources in this WIP file called thing. Won't go into why that is, but let me see. It was called Baz. No, it was not called Baz.
There we go.
That was called
There's
Baz.
a static.
Okay, there we go.
Yeah.
There was another one called Baz too. Okay, but okay, so this is the code we generate for the resource we were just looking at, and the first three, no problem. It all just works. It all very nicely typed. Don't worry about what the body does. That's not relevant here. But this thing here is where it gets kind of messy. And of course, I just fell back to the any. I'd like to be able to refer, because if I use self here, there is a thing in the Python typing package called self. And at first I thought, oh, great, that's exactly what I need. But self will actually refer to this abstract base class. Actually, wait, this isn't an abstract base class. Where? Hold on.
It's not. Yeah, it's not even deriving from my
Sorry,
class.
okay, this is the one. Because I was both importing and exporting that resource in that particular test, so that we were looking at the imported one where we're actually calling into the host to call the methods. This is the one that the guest would implement. So yeah, this is the abstract base class. Wait,
Seems to
no,
be
because
different.
hold on, that's a different one, isn't it? Wait, do we have? Finally,
that one looks promising.
This one looks good.
Yeah.
There we go. Okay. Yeah, so this is the one. And so, yeah, so if we refer to self here, that will refer to thing, not my thing, if my thing is the thing that actually extends this abstract base class. And so I don't know if there is anything in the world of Python typing that says that's equivalent to what self means for a trait in a trait for Rust.
You could use thing there, can't you?
But if I use,
you can't use thing there because it's not actually declared until the
class. Okay, yeah.
Well, even if I could, that's not what I mean. I don't want thing. I want whatever thing that's going to inherit this thing. So if this was Rust and I use self in the capital S self, it would not refer to the trait. It would refer to the implementation of the trait, if that sort of makes sense.
I don't know that matters here, because you're not declaring that this is exactly the type thing. You're declaring that it's any subclass of thing.
Well, that's what I would like it to say, but when I tried to use self here, which seemed to be the directive that at first I was pushed towards by Stack Overflow, it complained because I can even, maybe I could, I don't know if I can live code here and in any meaningful way. Stresses me out a little bit, but what it was complaining about was the type for self. So basically when I declared my thing and I actually overrode Baz in my thing and I use self there, then MyPy would complain, this doesn't actually override the superclass, because self in this case means my thing and self in that case meant thing.
That makes sense.
Yeah.
Those are different signatures.
Right.
When you're building a subclass, if you declare the types there to be thing, then I would expect MyPy to be happy.
Yeah, except it's not really what I want to say though. What I want to say, no, I think I think I tried that. Let me think here. You declared them to be thing. Oh yeah, why did not work? Because I feel like maybe it wasn't doing the subtyping the way I thought, but somehow when I tried to return a my thing, well, first of all, I want to actually get fields from A and B for my thing. And of course, this thing has no fields. And in Rust, I could do it. But in this case, yeah, if I say that they're things rather than my things, then I won't be able to do that, which I don't know, maybe, but
yeah, that makes sense.
yeah. So I think that was part of it where I was reaching for fields and then MyPy complained, hey, thing doesn't have any fields, and it's right. So I guess instead of reaching for fields, I could have some method that returns the field, but it was just the except declared in the base class, but I don't want that to be part of WIT or anything. The field that I was interested in and the type of that field was very much specific to my thing. It was an implementation detail that I wouldn't want to make part of the interface. So anyway, I don't want to spend a huge amount of time. Since you were curious, I gave you the run through there, but
yeah, I'm just looking at the MyPy docs right now. I guess so. A thing you can do that's not very satisfying is in the implementing class subclass. Declare the type parameters as the superclass thing, and then use
is there there's a cast? I think there's a cast method actually. Now that you're starting to jog my memory, but yeah, I think there is a cast thing. I've used that elsewhere. Wait, let me find that first, because I know I've used that. Oops. Okay. What was it? It was examples. Yeah, typing has cast. Okay. Yes, I can cast. I can cast, like what is it? Downcasting. So yeah, maybe that's the key there is I downcast it to those things to my things. And that provides a little bit extra. Yeah. That might be a way to pursue this.
Yeah, it's annoying because the person writing the implementation has to use it.
Right.
You can't just sort of generate it for them.
But at least it's better than any,
Yeah.
So
what about something like this? If there's any comments.
Are you chatting here? Oh yeah, let me
see.
Yeah,
it's in chat.
In the chat, yes.
Yeah. Static method. Last thing base. Okay, wait. Thing base protocol pass. Okay.
So yeah, that should work. The problem is that inside the implementation of foo, you only know that you have a thing base which doesn't have any fields.
So you have to cast. But I mean, no, I think we're converging on the same idea here. But yeah, you'd have in the body we would have to pass, or we would have in the body of whatever extends. Well, I guess maybe I don't quite understand, Elle, what this achieves. So you're saying that there would potentially be 3 levels of 3 separate classes here that so my thing would extend thing, which in turn extends thing base. And if I'm understanding that correctly, what would that give us?
I don't know. It's
I'm guessing maybe you were trying to solve the problem that you can't use the name thing inside the definition of thing.
Sure.
Right. Yeah, exactly.
I see what you're saying.
That's the only thing I'm solving here. Yeah.
That's fair. Yeah, no, that's totally reasonable.
I hadn't known that this typing.self existed, but that it's new in version 3.11. That's why. That seems like a very nice solution to this problem.
I think self would basically allow us to avoid kind of what you were. I mean, what Elle has proposed would definitely be what you'd want to use for like 310 and below. But yeah, I think.
I mean, what you really want to use for 310 and below is you don't have to. Let's see. The old way to do it is you put the name in quotes. You make it a string.
Yeah, I've heard of that. Yeah.
And then there was some effort to make Python not try to evaluate types as Python expressions immediately, and sort of implicitly wrap them up in strings or something for you. But then that caused other issues, and I think they had to revert it, and I don't know what the current state of it is.
Yeah, it was like something with that future.
Yeah.
It's like a future package of some kind. Yeah,
Mhm.
I saw a lot of different stuff when I was Googling for this, but yeah, I think what we've arrived at is probably the best that's available, which is maybe if you can rely on 311, which we can in this case, use the self type and then downcast, force the implementer to downcast if they want to access fields from the thing.
Yeah.
Yeah. Gotta make some notes here. Cool. All right. Well, thank you guys for looking at that. I guess the first thing on the agenda, which I sort of skipped over, is updates. I don't know if anybody has updates besides me, but I'll go first, and then you all can go late after that. Let's see, just continuing to work on resources support. I don't know if that's what I reported last time, but that's what I'm working on right now. I thought it was going to be like very naively thought it was going to be a 2 or 3 day thing. It's more of like a 2 or 3 week thing. I've also had to take some time off. So it's been a bit spotty, but I do have it more or less working. The details of, in particular, when to drop handles, I'm tweaking. Currently, I've got cases where I'm dropping them too early and dropping them too late, and that's causing issues. But turns out resources are a bit complicated. It exposed a bug in WASM time WIT bindgen that Alex and I had to track down, fix that. There was a missing feature in WIT component that we had to address. So it's all good. I mean, it's like we're fixing corner cases and various tools in the ecosystem as part of this project. So, but it's just a little frustrating that it's taking so long. But I think and I'm going to be out tomorrow and Monday, but I'm thinking by the time we meet next time, if I'll be very embarrassed if it's not all completed and wrapped up. Anyway, that's what I'm working on. That's all I got. Anybody else have anything interesting? Okay. The only other thing is, I don't know if you guys have been following the general channel on Zulip, but Andre, I'm not sure, I'm probably butchering his name, but the gentleman from the L4Tran project is interested in using WASM time to essentially compile Fortran to WebAssembly and maybe even Python to WebAssembly, and then convert that into a native executable. And he was excited to see this CWASM thing that WebAssembly can produce, but he'd like to basically make that CWASM a standalone executable that you can just, a native executable you can run. And so I said, well, you can do that if you don't mind having a Rust compiler and linker on your system. You just create a little, binary that uses WebAssembly. You can basically disable all the default features so you don't pull in crane lift and stuff, and you can just have it load up the CWASM and set up the WASI environment the way you like it, and you're off to the races. And it turns out he was really excited about that, and now we're gonna move forward and maybe try and package that as a .a file that he can then link in as sort of the last step in his L4Tran toolchain as a way to just kind of create native binaries that are sandboxed. So anyway, he was excited about that, and I was excited to be able to help him with something because I would like to cultivate that relationship as much as we can because L4Tran is very much of interest to us from a sort of scientific computing data science perspective, and getting the SciPy and the OpenBLAS and all that ecosystem working in WebAssembly, and that this seems to be by far the most active and most promising avenue to do that.
I'm having a little trouble figuring out how you would link something to the CWASM files as they're currently produced
Yeah, no, you wouldn't.
to
So
make it executable.
yeah, there was a lot of speculation about things we could do to like add to, at least optionally add to CWASM files to make them executable. And, you know, Dan and Alex and Chris all kind of chimed in on that. I'm being more pragmatic and trying to work with what we have now. And so is this gentleman. So the approach we're taking is, okay, it would be the responsibility of this L4 toolchain to call WASM time, or use it as a library, if you will, to compile to the WASM file to CWASM, and it's just your normal CWASM, and then it would separately use this already built .a file, call it like lib run CWASM.a or whatever you want to call it, and then link that together with another thing that it basically embeds the CWASM to produce an executable. Right now my proof of concept just uses the Rust compiler and include bytes. Does it include bytes to pull in the CWASM? But apparently he's got a vision of how to do this without requiring Rust, or the Rust would bootstrap it because we'd have to create the .a from Rust, but you wouldn't the end user using L4tran wouldn't need to have it installed. Is the idea, nor have a linker. Although I guess they maybe this is where I'm a little fuzzy. Apparently they're gonna, since they're consuming a .a file, obviously they have a linker of some kind. So maybe it's just kind of baked into their L4tran toolchain somehow.
Yeah, the key thing in there, I think, is the linker doesn't look at the contents of the CWASM.
Right.
It sees the entire CWASM blob as just a bag of bytes.
Exactly.
With a single symbol attached to it.
Yep. Well, cool. We can make this a short meeting if nobody else has anything.
I wanted to note, you've been talking about the self and cast stuff in the context of static methods, but I would think that this would also show up for non-static methods if they took an argument or had a result that was
it's true.
Also self.
Yeah, that's true. Yeah, so yeah, you're right. Let me just maybe say in methods,
In resource methods, I guess.
Take or return instances of the implementing class or something like that.
Yeah.
But yeah, absolutely.
But yeah, I don't think I have anything else.
Cool.
It's a neat little puzzle to wander through the typing stuff.
Yeah. Yeah, I don't know if there's been any, I mean, it sounds like other people are kind of disappointed with how typing has turned out for Python. I don't know if there's any projects, happening to maybe make a more ambitious system, but yeah, who knows? All right, well, thanks for coming, guys. See you around.
Good to see you. Take care.